questions 1 through 4 on the 2013 Grade 12 Euclid Math Contest. What is the smallest positive integer for which 113 plus x under the square root sign is an integer? Well, if you want 113 plus x under the square root sign to be an integer, then that basically means that what's underneath the square root sign must be a perfect square. Well, it's obviously greater than 10 squared, which is 100. 11 squared is 121, so it's most likely 121. So 113 plus x is 121, and that means x is equal to 8. Now, let's just verify this. If x is equal to 8, we have 113 plus 8 under the square root sign, which is 121 under the square root sign, and root 121 is equal to 11, and 11 is indeed an integer. So x is equal to 8 for number 1a. The average of 3 and 11 is a. The average of a and b is 11. What is the value of b? The average of 3 plus 11 is a. So 3 plus 11 divided by 2 is a. That means 14 over 2 is a, and therefore a is equal to 7. Now they tell me that the average of a plus b is 11. So a plus b divided by 2 is 11. That means a plus b is 22. Well, a we just figured out was 7, so 7 plus b is 22, and therefore b is equal to 15. And that is what they wanted us to figure out, the value for b. Charlie is 30 years older than his daughter Bella. Charlie is also 6 times as old as Bella. Determine Charlie's age. So Charlie is 30 years older than Bella. Charlie is also 6 times the age of Bella. So C equals 30 plus B, C equals 6B, so set them equal to each other. 30 plus B is equal to 6B, and therefore 30 is equal to 5B, and that means B is equal to 6. And therefore Charlie is, you can plug B equals 6 into either one of these. If you plug it into the first one, you get 30 plus 6, which is 36. So Charlie's age is 36. If 21 over x is equal to 7 over y, with x not equal to 0 and y not equal to 0, what is the value of x over y? 21 over x is equal to 7 over y. Cross multiply, you get 7x is equal to 21y. And then bring the y down here, bring the 7 down here. That means x over y is 21 over 7, which simplifies to just 3. Part B. For which positive integer n are both 1 over n plus 1 is less than 0.2013 and 0.2013 is less than 1 over n true? 1 over n plus 1 is less than 0.213. So flip them. So that means n plus 1. And of course you have to flip the sign. If you do this number, and meaning you could take the reciprocal, you will get 4.96. So that means n is greater than 3.96. Okay, so that takes care of this first one. Now let's look at the second one. 0.2013 is less than 1 over n. Again, let's flip them, take reciprocals. If you do that, you get n, and on this side, the reciprocal of this, as previously mentioned, is 4.96, and you have to of course flip the sign as well. So now we have n is greater than 3.96, but it's less than 4.96. Combine those into one inequality. N is less than 4.96 but greater than 3.96, and they told me that n is an integer, so the only integer it could be is 4. That's the only integer in that range. In the diagram, H is on side BC of triangle ABC so that AH is perpendicular to BC. Also, AB is equal to 10, AH is equal to 8, and the area of ABC is 84. Determine the perimeter of ABC. All right. So let's see what we can do here. Let's label as much as we can. AB is 10 and AH is 8. And I think that's it, right? They also told me that the area is 84. All right, so the area is represented, of course, by 1/2 base times height. So 1/2 base, the base is BC for that triangle, and the height they gave me is 8. So very quickly I can figure out that BC is going to be 21. So this distance from here to here is 21. Okay, so now I can use Pythagoras to figure out what is BH. So BH squared plus 8 squared is equal to 10 squared. So BH squared is equal to 100 minus 64, which is 36. And therefore BH is equal to 6. So let's put that here. This is 6. Now this is 21, this whole distance. So that means HC will be 21 minus 6, which is of course 15. And then now, again, using Pythagoras, we can figure out AC. So AC squared is equal to 8 squared plus 15 squared. So that's 64 plus 225, and that is 289. And therefore AC is equal to 17. And now finally we can figure out the perimeter. So the perimeter of that is 10 plus 17 plus 21. And 10 plus 17 plus 21 is equal to 48. The perimeter of that triangle, ABC. In the Fibonacci sequence 1, 1, 2, 3, 5, each term after the second is the sum of the previous two terms. How many of the first 100 terms of the Fibonacci sequence are odd? Well, let's write out a whole bunch of them and see what kind of pattern we get. So the first 5 are given, and then of course we just use the same rule that every term is the sum of the previous two. And when we do that, we get 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, and I think that's good enough. Now let's see what kind of a pattern we have. I'll put O for odd and E for even. So obviously this is O, O, E, O, O, E, O, O, E, O, O, E, O, O, E. Okay, well, I think I can figure out a pattern here. It's OOE. So they're saying when you write 100 of these terms, how many are going to be odd? Well, it seems like every 3 there's 2 odd. So using that, I can extrapolate. So in the first 99 terms, if you break those up, since every 3 produces 2 odd, 2/3 of the terms are always going to be odd. So in the first 99, 2/3 are odd, so that's 66 are going to be odd, and then the other 33 will be even. So they want the first 100 terms. So if you were to extrapolate this, say the 97th term, the 98th term, and then the 99th term, I don't know what those numbers are, but all I'm interested in is that they're going to be odd, odd, even. And therefore the 100th term will be odd, right? Because it goes odd, odd, even like that. So the first 99 terms will give me 66 odd, and then the 100th term will give me 1 additional odd. So 66 plus 1 is 67, and that's how many odd numbers there will be in those first 100 terms of the Fibonacci sequence. In an arithmetic sequence, the sum of the first and third terms is 6. The sum of the second and fourth terms is 20. Determine the 10th term in the sequence. An arithmetic sequence is of the form A plus D, A plus 2D, A plus 3D, A plus 4D, and so on, right? So we are concerned with what? How many terms we had? First, third, second, fourth, and 10th. First, third, second, fourth, and 10th. Okay, so obviously I have to get up to the 10th. So the 10th term is going to be A plus 9D. So this is the first, second, third, fourth, and this is the 10th. Okay? All right. So let's just use the question. The sum of the first and third. So this is the first a plus the third is a plus 2d. And they're saying that is 6. Okay? The sum of the second term and the fourth term, a plus 3d, is equal to 20. All right, so I got two equations, two variables. I can solve for a and d. From this guy, I get 2a plus 2d is equal to 6, and therefore a plus d is equal to 3. From this, I get 2a plus 4d is equal to 20, and therefore a plus 2d is equal to 10. Right? So any way you'd like to do it is fine. If you subtract these equations, if this is equation 2 and this is equation 1, if I say 2 minus 1, that's basically going to give me d is equal to 7 in a very quick way. Substitute d equals 7 back into any one of those, 1 or 2, and we get a is equal to negative 4. Okay, there we go. Now I can figure out the 10th term. The 10th term is a plus 9d. A is negative 4. D is 7, so that's negative 4 plus 63, and that is 59. So 59 is the answer to this question. How many positive integers less than 1,000 have only odd digits? All right, let's break this down into 1-digit number, 2-digit number, and a 3-digit number. Right? We can't go more than 3 digits because the numbers have to be less than 1,000. And the digits that we can use are 1, 3, 5, 7, and 9. Those are the only odd digits. If it's a 1-digit number, well, there's only 1 digit, and for that I've got 5 possible choices. So that's pretty straightforward. And those 5 possible choices are 1, 3, 5, 7, 9. What about if I have a 2-digit number? Well, for the first digit, I can put any of those 5. For the second digit, I can also put any of those 5. So 5 times 5, 25 of those numbers. And you certainly don't have to list them all. If it's a 3-digit number, the story is pretty much exactly the same. 5 choices for the first digit, 5 choices for the second digit, and another 5 choices for that third digit. So 5 times 5 times 5 is 125. So we have 125 3-digit numbers that only contain those odd digits. And now we just add them. 5 plus 25 plus 135. Sorry, 5 plus 25 plus 125 is 155. So that is the answer to this question. Determine all ordered pairs AB that satisfy the following system of equations. A plus B is 16. 4 over 7 is 1 over A plus 1 over B. All right, so I guess we just have to work with this one. The first one, there isn't much we can do. So 4 over 7 is equal to 1 over A plus 1 over B. So get a common denominator, top and bottom here by A, top and bottom here by B. So that means 4 over 7 is equal to B plus A over AB. All right, well, B plus A is given as 16. So substitute that in. We get 4 over 7 is equal to 16 over AB. Cross multiply, you get 4AB is equal to 7 times 16. AB, therefore, is 7 times 4, and therefore AB is 28. All right. So A times B is 28. So let's make I think that's it, right? There isn't really much else I can do here. So A is 28 over B. And I guess I just substitute it into here. So A plus B is 16. A plus B, so I've got A in terms of B, it's 28 over B. So substitute that in. I've got 28 over B plus B is 16. Now I've got only one variable, so I can solve this. So multiply through by B, and I get 28 plus B squared is 16B. Put everything on one side. B squared minus 16B plus 28 is 0. And I believe this should factor. B, 14, 2, negative, negative. So B is either 2 or 14. If you substitute those values back into this equation, you will get A is equal to 14 or 2. So that means my ordered pairs AB are either 14 and 2 or 2 and 14. And that's it for part B of number 4.